West-Calder fabrication is a cost volume analysis problem. You can tell from the data that was given. Let's take a look. West-Calder fabrication is trying to decide which of the following 3 cities to locate a new production facility. So we have a list of candidate locations and has gathered the following information about each: annual fixed cost and variable cost per unit of production. This is what I meant. You can tell a cost volume analysis problem. This is what's indicative, if you will, of that type of problem. Now, in that type of problem, sometimes you need to draw a graph, but a lot of it is logic, because take a look at the first part of the scenario. If this facility were to produce 5,000 units annually, oh, that's Q. Q equals 5,000. Where should West-Calder locate it? Oh, this particular question, just logic. The only thing that we need to do is to calculate the cost at each one of the cities at that particular Q equals 5,000, that particular volume of annual output, and see which one's the least expensive. So let's test them. Okay, Singapore. If West-Calder were to locate the production facility in Singapore, they would pay $30,000 annually regardless of what they did with the facility. Plus, they would pay $2 for each unit they produced annually, and the proposal is 5,000 annually. So, to calculate total costs annually in Singapore, so it's 3,000 plus 2 times 5,000, 10,000, total of 40,000. All right, now that does not yet answer the question of whether they want to be in Singapore or not. We have to test that against, it's just logic, Hong Kong. Okay, in Hong Kong, what are we told? Oh, lower annual fixed costs, 20,000 regardless of what you do, but higher variable costs, $3 for every unit produced. The proposal is to produce 5,000 annually, so this winds up being 20,000 plus 15,000, 35,000. And then to complete the test, Niagara Falls. Niagara Falls has a remarkably low fixed cost, only 10,000 annually, but we can see pretty high variable costs, $6 for every unit produced times 5,000. Okay, so that's 10,000 plus 30,000 equals 40,000. You might be thinking, oh, well, you got a tie. You have a tie there in terms of cost between Niagara Falls and Singapore. But wait a minute, you're right. That really doesn't actually, though, affect the answer to the question, because the answer to the question is, where does West-Calder want to locate? And West-Calder would want to locate at the lowest cost location, and the lowest cost location at Q equal 5,000 is neither one of them, right? 35,000 is the smallest number we have up there, so that makes it the answer to this particular question. They would want to locate in Hong Kong, because it's the smallest number. All right, now, next question. What is the point of indifference between Singapore and Hong Kong? Okay, a point of indifference is a condition at which you wouldn't care between 2 or more alternatives. Now, the issue of caring, here it's about cost, right? Which location is the lowest cost? You wouldn't care if the costs were the same. So the only thing that we need to do is figure out when costs would be the same in Singapore versus Hong Kong. Just logic. Cost at Singapore. How do you calculate the cost of the fabrication facility if it's in Singapore? Well, you pay $30,000 annually in Singapore, regardless of what you do, plus you pay $2 for each unit produced. And I don't know, here with the second question, nobody is specifying how many units that is, so I'm just going to write Q. But the issue is, I'm curious at what level that's exactly the same thing as being in Hong Kong. So cost of Hong Kong, well, that's the lower fixed cost, right? 20,000. How do you calculate the costs at that location? Plus $3, right, times the same Q. When would these two things actually be equal? That reveals the point of indifference. So this is what, subtract 20,000 from each side and subtract 2Q from each side. Oh, then that means I just revealed right there. Okay, right, when you produce 10,000 units annually, at that point, the costs in Singapore and Hong Kong are exactly the same. So we could call that the point of indifference. It wouldn't matter which location you were at, it would cost the same. Okay, fine. Now, this has all just been logic so far, right? Look at the last question in the scenario. Over what range? Notice no particular Q is recommended, no particular quantity. Over what range of production levels, which does refer to Q, that's what we mean, would West Calder Fabrication prefer Niagara Falls? You could try to tease this out algebraically. The fastest, best way is to draw a graph. Oh, right, which is why if you download the note frames, there is some graph paper handy to work with. Now, you say, well, I don't have the note frames. That's fine. You say, well, I don't have graph paper. Actually, that's fine as long as you draw very, very carefully, but you do need to draw a graph. Now, what is a graph? A graph is going to be an illustration of this dilemma of which of the three cities. Okay, now what are its features? First off, we need to define the axes. We'll have a horizontal axis. That's going to represent Q, the various levels of production levels, right? I mean, if I could even write that, production levels, quantity. The issue is cost. That's what the vertical axis is going to represent. Not just cost, as a matter of fact, but total annual cost. Oh, all right. Now, we do need a scale. I mean, any graph, you need a scale. So, let's see. A good scale for this particular graph would be, let's let, on the vertical axis, the annual cost, let's let every grid square be $2,000. The reason being is you can count then 1, 2, 3, 4, 5. That's 10,000. You know, these are sort of important milestones. 1, 2, 3, 4, 5. That makes this 20. 1, 2, 3, 4, 5. That makes that 30. And 1, 2, 3, 4, 5. That makes that $40,000. Varying levels of cost. Now, varying levels of production. Let's let every grid square be 500. So like that's 1,000. That's producing 2,000 annually. Producing 3,000 annually. 4,000. I'm trying to find. Okay, whoops. Right there would be 5,000. 6,000 annually. 7,000 annually. 8,000 annually. 9,000 annually. That right there would be Q equals 10,000. So that's 1,000. That's 10,000. All right, now I'm all set. The only thing I've done is I sort of set up the space. Because what is it that we're graphing? We're graphing the three cities. We want to graph them one at a time. What is it that we're graphing? We're graphing the cost of being in one of the cities in particular over varying levels of production. Oh, like the cost function of that particular location. Okay. Now, wait, look at the original data. The original data has linear variable costs. You say, yeah, okay. Oh, which means super easy. Each city is going to look like a straight line on this graph. Now, if I have found 2 points on a straight line, I have found the line. Let's draw Singapore first, only because it's at the top of the table. Okay. one point on the line that represents the varying levels of cost at the Singapore location over varying levels of production volume. One point that's super easy to find is the point at which you locate in Singapore but you don't produce anything. You say, yeah, you know, right here. If you were to locate in Singapore and not produce anything, what would your annual cost be? Well, that is just by definition, the fixed cost, right? The answer is, yeah. I found a point on that line. It's right here. Now, I only need for Singapore one other point for some certain production level, exactly how much it would cost, and then I'm ready to draw the line. I could pick a number like 1,000 or 3,000, and I could calculate the cost in Singapore, or I could remember that we did do that already, right? We did that in particular for Q equal 5,000. We had determined that to answer this first question, it would cost 40,000 annually. Great, I'm just going to use that work because this was 5,000 right here as a production level. So I'm going to trace that line up to, right, there we go, 40,000, right there. If you have found 2 points, you have found the line. So I draw that and I label it immediately because I don't want to lose track of who this is. This is Singapore. Varying levels of cost over varying levels of volume. Perfect. Now, need to add Hong Kong. Hong Kong, if I were to locate there and then not actually produce anything, it would still cost me 20,000 a year. That means that's 1 point on its line. I'm going to use the work that we did for the first part of this scenario. At Q equal 5,000, Hong Kong costs 35,000 annually. Right there's 30,000. The other dot is 40,000. So halfway in between is 35,000. 2 points. Describe a line. Just connect them. That's Hong Kong. Oh, and it looks like there's a point at which Singapore and Hong Kong cross. Why don't I draw that out a little bit? Singapore here, Hong Kong here. Oh, interesting. In that point, my graph came out pretty good. It's right over 10,000. You say, yeah, okay. Why is that important? Because that is part B of the problem. The point at which the line that represents costs in Singapore at varying levels of volume and costs in Hong Kong at varying levels of volume, the point at which they cross is the point at which for a certain, that's what I said, oh look, it's right over 10,000, at a certain production volume, they cost the same. That was that point of indifference from the second question. You say, well, oh, okay, fine. That's what it looks like on a graph. What's this got to do with answering the last question? The last question's about Niagara Falls. We needed to do this to answer that question about Niagara Falls, but we need to add Niagara Falls now to the graph. Okay. If you were to locate in Niagara Falls and not produce a thing, the fixed costs at Niagara Falls are 10,000. We already know from our work on that first question that if you're to produce 5,000, it's that same 40,000 right here. This is what costs in Niagara Falls look like over varying levels of volume. I want to Niagara Falls. I want to label that. Okay, yeah, that would make sense. Niagara Falls, the costs start out low because it has that really low fixed cost, but they climb really fast because it has that really high variable cost. Now, wait, what am I supposed to do with this graph? Remember, with any cost volume graph, not just West Calder fabrication, when we're done adding locations, what we're really interested in is what I'm highlighting right here. It's the lowest line in each case or across. See what I'm doing? So that's what we call the efficient frontier. That is indicating where we would want to be under various levels of volume. Because the question was about Niagara Falls, and I can see that there is a zone on which Niagara Falls, this is it right here, it is the lowest cost. It would be essentially the preferred location. It's not going to be the preferred location forever because I see that there's kind of this central zone of quantity of which Hong Kong is clearly preferable in terms of cost. But then if volume is high enough, Singapore takes over because Singapore has the really low variable costs. If volume's high enough, and then Singapore would be preferable. Questions about Niagara Falls. Well, I can see that it is everything from zero. Like if you were to locate somewhere and for some reason not produce anything, you definitely would wish you had located Niagara Falls because the fixed costs are so low. It is zero up to some certain point. Now how am I going to find this point? That's another point of indifference. Just as this right here, remember I was remarking? That right there is the point of indifference between Singapore and Hong Kong. This is a point of indifference, and it's a key to answering our question. Now wait a minute, it's the point of indifference between Niagara Falls and who? Niagara Falls and Hong Kong. Okay, so the key to the best answer to this question is to find the point of indifference between Niagara Falls and Hong Kong. Okay, point of indifference, when would they be the same? Because it's essentially a tipping point. Oh, okay, well then Niagara Falls, you calculate the cost by taking 10,000 and adding 6 times some quantity, and this is really asking when is that the same thing as taking 20,000, the fixed cost in Hong Kong, and adding 3 times the same amount. Alright, so that's what 3Q equals 10,000, or Q equals 3,333 and like what, a third? Oh, now, wait. That's the point of indifference. The question is over what range of production levels. Well, it definitely starts at 0. You know, to answer the question, from 0 to, now you might be tempted to say 3,333 and a third, and okay, it's not strictly wrong because it is up to the point of indifference, although remembering, 1, at the point of indifference you don't strictly prefer Niagara Falls, and 2, with this West Calder fabrication, is it possible to make a third of something, whatever it is that they're producing? We really don't need to stress about the 1/3 though, because a much more elegant way then to respond to this question is when would you strictly prefer Niagara Falls? Well, it would be from 0 to 3,333 even. Because if you were to bump it up to 3,334, the other side of that fraction, that's where you're tipping over into where you do prefer Hong Kong, not Niagara Falls. It's the other side of the point of indifference. So this is the definitive range. You know, if production has to be in whole numbers, that right there is the definitive range from 0 to 3,333 units annually, over which, for a fact, yes, you would want to be in Niagara Falls.